Okay, good morning everyone. Today since your TA already have additional classes like last 2 weeks, so this week there will be no TA class, but I think your TA will give you some homework, I think, or maybe practices. But for my class, I think I can review a little bit the last discussion, which is the Taylor and Maclaurin series. I think this is the recap. All the functions that can be described into a power series using the Maclaurin series. So by Maclaurin series, we can describe all these atypical functions. We can describe and then write within this power series. Okay. Remember that how we can write that is basically taking the f of x equal sum that is the original set for the Maclaurin series. So as long as we can arrange this, So how we do it? So especially if you don't want to memorize this and you would like to memorizing this part is good, but it is better if you know how to get it. Okay. So basically what we've done here is we take the functions, for example, taking the functions of cosine, and then we take the derivative, and then take derivative again, and maybe until the third time. Okay, now we have all this variations in derivatives, the first, second, third, fourth. And what we have done here is basically we are making the f and x, right? And then what we're going to do is we plug in 0 to make it into our Maclaurin. So we take x equals 0. So taking x equals 0, so we write here f0 is 1, right? And then f prime 0 is 0. This will be -1. This will be 0. So every time we have sign, we have 0. So the fourth derivative is 1. And you could also observe that it is going to be alternating between 1, 0, -1, 0, 1. And then we can ignore the 0 part, which means we have only n equals 0, n equal to 4, and you could guess the next part will be 6, 8, 10, and so on and so forth. That's why within the arrangement, the cosine, it will have an even number. Okay? An even number. So from all this arrangement, we could make out and put into our original Maclaurin. So we can make, for example, this is the original expansion. We could write this first. This is something that you need to familiar with. Okay. So if you're still not sure how to do it, then it means that you need to get this concept already. Okay, you need to understand this concept already. So you just put, this one is 1, so 1 plus, this is 0, and then negative 1 here, so -1, oh, sorry, I forgot the x. This is x squared plus x cubed plus, okay. So we have 1 plus 0 plus minus, this is minus, or minus 1, and then plus 0, and then plus x with power of 4, and then minus that. Okay. And this is precisely what we have here. Okay? And you could describe this within this. Same way you could try the last two, the tangent universe and the ln. Okay, since last Friday we didn't record the class, but I tried my best to make additional information. I think only 40 minutes above last Friday, so you could check that out if you didn't come last Friday about the Taylor and Maclaurin series. Okay, now my plan for today is getting some practices. So let's say we start from number 3. Okay, number 3, maybe not all numbers, but maybe start with number 3. So we have this f with derivative n at 0. You have n plus 1 factorial, which means this will be the Maclaurin, right? The Maclaurin. You can see this the setup, and then it's asking you to find the Maclaurin series and then the radius of convergence. So basically, we find the series, and then after we find the series, we test the convergence, or we check the convergence, okay? Checking the radius. So remember, the original setup for the Maclaurin is this. Always start from this. Okay. And then the top one here is our question here, right? From our information there. So we could substitute. And then we can cancel this factorial, right? Okay. Remember that. Let me write here. If you don't understand, this is because this is equal to this. So we have n plus 1 as a leftover. And then take the ratio test and check the ratio. So suppose, okay, let me write here, suppose an is n plus 1 x power of n. I suppose that is our an. Now we take the n plus 1. So n plus 1 plus 1, so n plus 2. X n plus 1 divided by this will be n plus 1 x power of n. Okay. Now we can cancel the x with power of n, and we have x as a leftover, right? So we get n plus 2, n plus 1, and then with x like. We could take the limit of this part, limit as n approaching infinity, which gives you equal 1, okay? Does anyone still have confusion why this equal 1? This one? Okay. So n, remember you have limit, you have polynomials. If you have the same degree, then we can cancel that out. Or you can also think this, okay? Let me write here. We can divide all by n, so 1. Okay. Within the limit, this will be 0, this will be 0. So this will be 1. Okay. So this will be 1. So we get the conclusions that this will be equal to just absolute value of x, which means that to be converged, this ratio need to be less than 1. Okay, that is on the ratio test, right? So the radius of convergence need to be equal to 1. You will notice immediately, whenever any equation you have here, if it is multiplying your x, that will also determine your radius. For example, if the result is 3x, which means your radius becomes 1/3. Okay? And it doesn't need to be x. It can be x minus 3x minus 4. And you can multiply that with 2, for example. The radius becomes 1/2. Okay. So how to know the radius is from these expressions. So whenever you get x, it can be x or x minus something or x plus something. It means that it has the interval. Right? It has the interval. This x means the center is x equals 0. Okay, x equals 0. Okay, this is number 3. Maybe number 4, because number 4 I think also similar. So it's asking the radius of convergence of the Taylor series. It has given you the information that the f is centered at 4. Okay, centered at 4 means that it's x minus 4. So you have the fn, the f derivative of n at 4, it gives you this interesting fractions. So what should be done? What should we do at the first, as the first steps? What should we do? Any idea? Let me read the questions first. Okay, read the questions first. My suggestions: every time you have a question about Maclaurin Taylor series, the first thing you need to write down, like when you don't know what you need to write, you need to remember how to write the original setup. This is for Maclaurin. How about the Taylor? The Taylor is the original one, which means that the 0 should be a, and this x should be x minus a. Okay? That's the first thing. That's the first thing. So let me write here. This is number 3. Okay, this is number 3. Let's say number 4 is here. Okay. So number 4. Let me write Taylor series. Taylor series is and let's write a like that, and then the same over n factorial, and then x minus a with power of n. Okay, that's the original Taylor series. Now we take a is equal 4 because it's required for the questions to be equal 4. So then we can write down the Taylor series as fn 4 over n factorial x minus 4 with power of n. Okay, and then we know that the question says that the fn4 is equal to this. Then we need to apply this part. So exchange all these terms. So this will be negative 1 with power of n factorial over 3 with power of n plus 1, and then n factorial, right? And then x minus 4 power of n. We can cancel this part. I think we have, so this is the Taylor series. So this is the Taylor series for f centered at 4. And the next step is taking the radius of convergences. So we need to check the ratio test. So we need to apply ratio test. So apply, so let me write here, apply ratio test. So a n plus 1 over a n. So we need to check the ratio. So it will be negative 1 over n plus 1 3 n plus 1 n plus 2. So be x minus 4 n plus 1 multiply with this, the an, but we are going to switch over. So 3 with power of n plus 1 Okay, remember my suggestion when you take the ratio test, there will be many cancellations here. Okay, so do not be intimidated with this complexity, because it's actually quite simple. You see that every time you have this negative 1 n plus 1, this is actually negative 1 with power of n multiplied with negative 1. Right? We can simplify this n plus 1, which you can also taking these cancellations with this, which left is negative 1. X minus 4, again n plus 1. We can cancel with this, and this will be resulting in just x minus 4 at the top. Okay, so we do that cancellations over here. So let's say we take that, so we have negative 1, and then we take that, and we have x minus 4, and we have take that, and we have 3 over there, and then done. We can write this as, let me put this a little bit to the left. Okay, so we have, and let me put the limit at the front. So negative 1 x minus 4 n plus 1 3 n plus 2. Okay, we can factor out 1 over 3. I think we can make it a little bit closer there. So 1 over 3 we can take out, and then x minus 4, and then limit, we concentrate the limit on only for n, and limit value is the same as before, so it's equal 1, which means we are going to have 1/3 x minus 4 need to be less equal 1. So what will be the radius? Radius will be 3. Okay, so radius is 3. So R is 3. Yeah.
Would it be minus squared?
But the absolute value.
Oh,
Yeah. Item number 5 until number like maybe 20 or maybe 18 here. You can try to find, especially the 11 from number 11. You can try to arrange by taking the Maclaurin series. You get the functions, you derive maybe several times, maybe 5 or 4 or 5 times. Like for example, the f of x is equal 1 minus x with power of -2. We can derive this maybe 4 times and then arrange the setup. Take the x equals 0, check the value, and then you get the expansion. And after that, see the patterns and find the series. Just like what we've done with the previous functions. Okay. For some case, for example, the e with power of -2x or sine 3x, we know sine x, right? We know sine x. We know the power series representation. What we can do is we can substitute 3x to the x. So we can change the whole expansion, changing x with 3x. So usually you have x with power of n, right? Change that x with 3x. Okay. Which means this one. You have this, okay? You have this, right? So change this x with 3x. Okay, and then you can also change from this part here, change to 3x. But you can, if you just change this to 3x, and then that's it. You can substitute the 3x into here, which gives you the sine 3x. Okay? Or if you have the e with power of -2x, for example. -2x, you can just changing this x with -2x, and then that's it. That's it. We can do substitute like that. Or if you want to confirm and try yourself, like the arrangement, you can also try that. Okay? And I think I'm so suggesting you can familiar with the process. Or if you have the x and then e to the x like this, it means that we just multiply x to the e. So we multiply the series with x. So for example, if we take multiplication with x for e to the x, it means that we are going to multiply this, right? So multiply this, which means this is going to be +1. Okay? So as easy as that. Okay? We can check that out. Okay. Now I think what I want to show you is another question.
Can you go again?
Which one? This one? Okay. So the next part of the question that I would like to share with you is, wait. Okay, I think the left part here, the same thing what we have done. So we can use the table, the previous table, and then we can substitute the x. We can substitute the x with all these terms, and then multiply. If we need to multiply with x or x squared or any terms, then we just need to multiply the series. And also the series, like this one here, we can evaluate the limit using the series. Usually we take the limit, and sometimes we are using L'Hopital rule, or sometimes we just take the taking some modifications in algebra. We can do that as well, but the interesting for the series is we could rewrite these terms. All these terms that we can exchange to series, we can change to this expansion. Okay? So that's one way to solve the limit. Okay? Sometimes maybe make it more complex or maybe longer, but sometimes we will make more simple. For example, let's say number 67. So we take the limit. Let me write here. Okay, we know that the ln is started from the. We can check the ln here. Okay. The ln is started from x minus x squared over 2 plus x cubed over 3 minus x with power 4 over 4. So it's alternating, and then you can see this. Okay, it's very similar to with e, but the ln it doesn't have the factorial. For e, it has the factorial, and then it starts from 1. So the interesting thing is we need to make sure that it starts from x positive. So we need to make sure that the alternate series is correct. Okay. So it's positive, negative, positive, negative, not negative, positive. Okay. So it starts from positive. So we can write. So based on that, already right here, that the ln will be x to the power of n over n, like that. So we could change this. So x minus the ln, let me write in terms of different color. So x minus x minus 1 over 2x squared plus 1 over 3x squared x cubed minus okay, let's just write dot 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 to make sure that it's expand to the right side, and then over with x. We can factorize the, or we can just cancel this x with this x. So we have, so it's become positive like that, and change all the sign. Actually, the expansion, it doesn't matter because we are going to have a limit. Oh, I forgot to write the limit. Oh, x squared, sorry, x squared. And again, the same thing with the limit concept. So we can write limit. And then we can just divide all the terms with the x squared. So the first term becomes half, and it will be x squared, x cubed, and so on. Okay, so you can write this will be half and all the x component will be 0, right? Because limit x approaching 0. So this will be half. So sometimes using the series like this, maybe you can solve limit quickly, but sometimes maybe not so fast. So you need to decide how to solve the limit. Of course, you can check using the L'Hopital rule. We can derive x minus ln. So it will be 1 minus 1 over 1 plus x, and then this will be 2x. And check if that is still 0 over 0, we can derive one more time. And then until when we check it's not 0, it's not 0 over 0, then that will be our value. Okay, you could check the other part as well, especially if, so for example, this part here, I think this one no need, this is binomial, so I think this, the first one, the sine x, the tangent inverse, the cosine x. So number 70 you can skip, because I think we skipped the binomial for our class. And also sometimes the question is asking if we multiply or divide. Okay, I think this will be later on. Okay, this one. Okay. Sometimes the question is asking if we have this kind of function which is going to be composed of functions that we described in the table before, right? So we have e and we have cosine. The question is asking, finding the terms. Like sometimes we need to find 3, 4, okay, but mostly we find 3 terms. So what should we do? So because seems to be multiplications, then we multiply. So we need to multiply all the terms, like the x, x squared, and so forth. Both functions, we need to multiply the terms. Okay? And sometimes we need to divide, sometimes we need to multiply. Okay? So, for example, the number 73. So we could write, maybe first is e to the x. This will be is that. So if we take the negative x squared, then we have negative x squared, and then with power of n, like that. And we can describe this in within each terms. So start from 1, right? When n equals 0, and then n equal 1, this will be negative, and then n equal 2, so n equal 2 will be 4, right? 4. So negative x squared, so x with power of 4, and then the same thing here. And then the cosine x, we know the cosine x is 1 minus all the even number. So as a conclusion, the e and cosine x, this will become, so we need to multiply all this. So we need to take some times to at least getting some terms, because we know that the terms at least having a constant x squared, x to the power 4, this is the same. So we are expecting that the result, the terms will be at least having 1 x squared and x to the power 4. So we check some part of it. So we just checking up until degree 4, so check or multiply up until degree less equal 4. Why? Because the question is asking only 3 terms, right? 3 terms. So checking 1 to that. So we have 1. And then the second one, we have minus x squared 2 factorial. Or maybe just 2. Let me just write 2. And then again, the third one, plus 4 factorial is 24, right? 24. And then taking the other part here, maybe check with different color with that. So that will be minus x squared minus plus x with power of 4 divided by 2. And then what else? So I will skip the one that makes the degree over 4. So like for example 2 with 4, I will skip for now. So we concentrate finding the 2, 4. Okay. So what else? So we have this and this, right? Okay, and that will be the last terms. So this will be the last terms. So plus 4, 2 factorial. And it should be having more, right? But we only need the first 3 terms, which means we have 1 minus this becoming 3 over 2 x squared, and then we have and also this one. This will be 1 plus 1 over 24 is 25 over 24. So this is the first 3 terms. So this is first terms, second terms, the third terms. Okay, this is all the first 3 non-zero terms. So one way is we can multiply. Another way we can divide. For example, if we divide, for example, the secant. Okay. So if we take the f of x equals secant x, we know that the secant is 1 over cosine. And we know the cosine, we just write here over here. So 1 minus x squared over 2 factorial plus x with power of 4 over 4 factorial, right? So we can divide 1, make a long division, divide with 1 minus x squared over 2 plus x with power of 4, 24 plus minus dot dot dot. So check with 1. So 1 will be 1 minus. Remember that you need to just still need to write this dot 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 because it's actually the expansions. So we take subtraction from here. So subtract this, then we have half x squared minus x power 4 24, and then plus. Okay. So we have plus half x squared minus x power 4, and then let's just stop until there, and then plus dot dot dot. Take the subtractions. This will be cancelled. So negative 24 plus 1 over 4 should be 1 over 4 is 6 over 24. So 6 minus 1 is 5. Positive, right? And then plus dot 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 dot. And this will be plus 5 over 24 x over 4. Multiply this. And since we don't really much care about the rest, so we say that, okay, this one plus dot dot dot, this is the first 3 terms. So the first terms, the second terms, the third term. Unless the question may be asking 4 terms, it means that you need 1 more here. Okay? But since it's only 3 non-zero terms, so we only care the first 3 terms. Okay? Okay, I think the rest of the questions I will try to make out on Wednesday class. We have another review and practice for almost 1 hour, for 1 hour. And after that, we need to move on to another sections. But it seems that we might have a quiz next week, okay? Chapter 11. So maybe Thursday, not this Thursday, next week. So chapter 11. So let me write here. No. Okay. So 26. Quiz chapter 11. Okay, any questions so far?
How about the midterm?
Midterm, interesting. Midterm will be Friday the next week after this quiz, but the Friday one. So November 3rd. Okay, November 3rd.
I'm not here.
Okay. So maybe changing the dates. So maybe this week the quiz. Okay, so that's the only way that I can make it.
Or maybe other wake-up day for her,
When?
up to her, but I think the
Okay. So I think this will be. Do you prefer morning or evening quiz?
doesn't matter.
Is it okay like a morning, like faster, right? Like 25 Wednesday. Yeah, for the midterm. Yeah. When you will be back?
5 November.
Okay, still okay. We can rearrange the other dates. Okay. And the 3rd November, some midterm. But while we are continue our journey to quiz and midterm, we may have another chapter. Okay, so chapter 12 and 13. So I think that's it for today.